gonna get started. Anybody, everybody hear us?
Good.
Appreciate you coming. Just a quick introduction. Steve Bluestone and myself, I'm Mike Cleary. We've been ICF junkies for a while. Steve has developed with ICF since the 2006 or 7. I've done ICF since the late 90s and did my first mid-rise in 2004. And through the process of doing multiple projects, we've come up with I thought would be, or think would be, the next revolution in ICF would be panelizing the ICS, and we want to bring you guys up to speed and tell you what we're doing and why we're doing it, and hopefully I've seen a lot of different block manufacturers here and can start spreading the word about the benefits of panelization and the time savings that it does garnish when you employ it. I'm going to turn it over to Steve Bluestone. He's basically, we're going to get into a scripted presentation, and then we're going to open up to the floor basically to get your questions, because more so we'd be interested in knowing what questions you want answered in lieu of what we're going to tell you. The bottom line is panelization saves time. If we're able to cycle whatever floor cycle time you have on your floors, whether it be 1 week, 2 weeks, 3 weeks, no matter what you say or do, if you're doing 1/3 or 1/2 of that work in another place prior to that floor being ready and you deliver it, you're going to save exponentially in time. With that said, I don't want to get too far ahead. I'm going to turn it over to Steve. He's going to go through a presentation for a little bit, and then again we're going to hopefully open it up for questions from folks.
Don't worry, you'll be hearing from Mike in 3 slides. He's going to carry most of the torch here. So, manufacturers, raise hands. Just want to know who's in the audience. Architects, good. Maybe tell stories about architects. Engineers, no. And contractors who work with ICFs, okay. Has anyone in the room not ever heard of an ICF? So we could leave out the 101. Great. Okay, so Mike was wrong about one thing. My organization, the organization that I used to work with, and my brother is still working with it, sitting in the back there, started with ICFs and started thinking about doing a building in 2007, program in 2008, finished it in 2010, and basically didn't look back. And this is the first building that we did with ICF. One thing I can say for sure is that none of you are going to sort of hold me up as an example of building the most beautiful buildings in the world. These are, a lot of the buildings we did are affordable buildings, so you didn't have tons of budget, a lot of money to a lot of fluffy things, big curved walls, no curtain walls or whatever, or very few. And the air conditioners in these windows, that was my decision, and it's ugly. But I'm mostly about trying to get really efficient buildings. Anyone in the room heard of Passive House, the program? It's like kind of like LEED on steroids when it comes to energy. So that's been a big goal of mine, and the Bluestone organization now is carrying on and building a lot of buildings that way. So kind of trying to put up a building where you're going to save about 90% of your energy costs for heating and cooling, 90. And that's a big number. There's a lot of the buildings that we put up, we built, we developed, we built, and own and manage, and saving 90% on energy is a good thing. So that's the first building we put up on a block in Queens, Regal Park, Queens. If you take a look on the slide that you're looking at here, way off to the left is the roof of that building. 10 years prior, we finished 2 other buildings. The 2010 building was 6 stories that you saw on the previous slide, 50 apartments. The other 2 buildings, twin buildings put up together, 66 apartments, 7 stories. You can see they're all facing the same direction. They get the same kind of sun, wind, etc. Some train tracks there. The buildings on the right in 2000 were block and plank buildings, CMU, metal studs inside, 3.5 inches of some pink stuff or yellow stuff, and sheetrock and bricks on the outside. The building on the left, of course, was our ICF building. Again, I'm just going to be talking about energy, and then we get back to Mike. This chart here shows all 3 of those buildings and the gas bills for 7 years. You can imagine which one is the ICF. I don't know if you can see the colors, but there's 2 lines at the top, and the ICF building is at the bottom. And now we're building more buildings that are going to take that bottom line and drop it even further down by improving the air tightness around windows and ventilation systems. So the ICF really worked. And we were building this passive house wall. And in your travels, if you get energy, people want, you all know about the benefits, but if someone wants to know how good it is, you drop that word that their ICF wall in a big building is going to be a passive house wall already. They don't have to do anything. It's going to register, and you're going to get the job. An outside organization in the New York City area, a third-party energy consulting company, called Stephen Winter Associates. They're pretty large, kind of hundreds of people working there. They looked at a lot of buildings, and the fine print on this chart is that they have 10, 1, 2, 3, 4, 5, a dozen, 14 buildings here that they've been watching over the years. Across the board, many developers in the New York City area who are building quote-unquote green buildings. The red on the left is the building that I showed first, our first ICF building back in whatever year that is, let's see. Well, completed in 2010, so I guess the date's sequential on the bottom. You can't see it, but the completion dates. And the building on the right side of the screen is also an ICF building, and it's a little higher on the energy use only because the building on the left, we use natural gas for heating. Natural gas, you pump the gas to the building, you burn it in a boiler, and that's it. You get all your heat out of it. When you're using electric heat pumps to heat a building, someone's got to burn gas or coal or uranium at a power plant somewhere. And by the time the power gets to your building, you've lost 2/3 of it through the transmission losses. So the building on the right, even though it's using more energy, because it's using more energy because of the electric heat pumps. So if we put a lot of solar panels in a wind turbine, then that number would come down a lot. But the building on the right is also ICF, and not the passive house. And the passive house buildings that we're doing now with ICF are going to take that number and bring it way down to be beating the first one we did. So I guess my point here is that if you didn't know already how good it was, now you can see using ICS what it does on the energy side, the cost side. And I'm going to throw it back to Mike.
Some of you folks know I've been trying to play around with panelization for a couple of years. This is a shot of a hotel I did out in Uniontown, Pennsylvania, outside Pittsburgh. I couldn't get concrete to the site on temperature. I can pour an ICF, as you know, in any weather we want. And I sat there with a dozen guys for like 2 or 3 days back in 2014-15, doing nothing. So we basically, I said, this was a helix job where I didn't have to put any horizontal rebars in it. And I just sat there one day, I said, well, why don't I just put these and glue these things together inside a heated environment? So I took a couple trailers on site, basically put a couple guys there, salamandered it, heated it up. I think about 8 hours later, with probably 4 guys, we built 1/3 of this hotel room floor. It didn't have no windows or doors in it, so I'm not going to make it sound like it's too big of a deal. But the next day, we placed them all in 2 hours. And I just sat back and I just had one of them moments that just said, wow, did I really just do that? Since that day, I've been trying to literally bring this into a full-fledged manufacturing process where it's going to be economically feasible to panelize, as well as make the ICF process, installation process, more consistent and efficient. The bottom line is this: in the ICF panelization world, we're not inventing nothing new. We're just stacking the block inside instead of out. The labor requirements are going to be only about 20% less than what you have out in the field. If you have a crew of 12 or 14, I got a crew of 8 inside our factory. We're going to go to automation. So basically what we do is we take and I gotta see where these panels are. Basically, if you have a 3-week floor drop transition, basically, if I can take a week off each floor, we're doing a 16-story building in Mount Vernon coming up in probably the spring and summer of this year. If I can take 1 week per floor off that project's schedule, I'm gonna take anywhere from 3 to 4 months off their overall schedule on their superstructure. Superstructure dictates everything. Everybody follows after the superstructure. If I have a 3-week turnaround per floor, and we'll all agree that shag your inventory, break it out, do your layout, build your wall, bucket, okay? What's that gonna be? 60%, 70%, whatever it is, it is. The other is gonna be brace it, pour it, and strip it. If I show up at each floor plate with the first done, and all I'm doing is slinging in 40, 50-foot panels, I am gonna just, again, without being a genius or a magician, I am just literally doing work at a time you're not because your floor is not there. It's simplicity as any panelization, SIPs, wood panels, or whatever. It's just that in this case, we're trying to add as much more insulary benefits to this. Waterproofing can be done inside the warehouse. Brick ties can be done inside the warehouse. We can use actually embedded brick ties. In New York City, you gotta wait for the wall to get poured for them to come out on the outside of the building. So they're forced to use offset Tapcon for every brick tie they have to put on their building. I'm gonna let the mason pay us to come up to our factory and just use a simple, like Fox has got a little simple bladed embed. I could go down insulary savings all the way from winter conditions across the whole gamut. Some of the challenges we've had to do was, well, I always knew I could pour and stack a wall. I've done that for 20 some years. And I know I can pour it and strip it. It's just, how do I make these things this big, transport them, and then lift them in a spot where they're gonna be integral, intact, and still efficient. And that's what we've been doing literally for the last year. We opened up a warehouse, and we've already moved, that's our actual new warehouse with our gantry crane and everything, and we're actually we're setting up production like where if we know I have 2,000 linear foot of wall on one floor, guess what? I can produce 2,000 linear foot of stock wall. Then we chop it in whatever section. So we started toothing in and keying in all our components, T's, 90s, and everything. And I found it, well, we're gonna have cold joints anyways on these seams. So why don't I just component the 90s, component the T's, and just build inventory wall straights? From transportation standpoint, that saves a lot of space, because if our first shipments to Clarkson or Brooklyn project had corners on it. So basically, when you stack these on the trailers with that corner, and this is just the vetting purpose of learning, is just that, well, you just impeded all the other straights that can go on there. So instead of me carrying 300 to 400 linear foot of wall with these with the 90s and the T's on there, you know, you're only gonna carry 200 to 300 linear feet. So these are just learning curves that we are going through as a manufacturer of trying something new that a lot of people haven't done. Bottom line, all our block is inside, it's not outside. The waste factor is 0. These right here are cutouts. What I do, as you know, you guys might come up to a window, you stop, you'll cut your change off, move on, go to the next one. I block right through because we adhere every block, vertically and horizontally. So then what I do is I cut out the full 5 foot by 6 foot sections, and then you'll see another line eventually. In fact, the cover of Concrete magazine this month has all them walls. If you look at these little blocks, Flint's blocks next to it, they're all glued back together. So then I recycle these all in the same project. We're down to probably less than 0.5% waste factor.
When Mike says he recycles, we're taking those big window cutouts and gluing them back together and making a new wall instead of throwing them into a dumpster.
And actually, that was just let's try it and see if it works. And it does. It's just that one of the things you learn is go ahead and give yourself factories. Don't go to a 4 and a 3 where you got a 7, you know, between your blocks. So make sure you cut your ends off so when you put them, slice them back together, you're dealing with straight, you know, all your strips are lined up and you don't have any issues. Cost comparison, I'm going to give you the pricing for New York City, all right? Everything works off market index, so whatever your market index compared to New York City is, you can probably bring that back. But an 8-inch reinforced CMU is $22 a foot.
Non-union.
Non-union, and also, that's not finished. You don't have any, you'd have to Z-fur it, you'd have to put whatever substrate on the outside for your exterior finish, you'd have to foam it and insulate it still. Right now, you're about 28 to 32 all in for that. In 8-inch ICF wall, every day of the week, we'll do 18 to 22 foot, $22 per square foot, depending on the vertical. If you go up this, you know, to anything above 10, 12 floors, you're going to cycle a lot of 12-inch and 10-inch cells on your first couple floors. So because of that, obviously, you're pouring a lot more concrete. Your per square foot price is going to go up a little more just based on volume. Advantages to the builder. Again, this goes through this is where panelization rules. The cost price of me stacking walls inside my plant and then having to transport them, I'm probably going to say I'm not going to be too far from the stock ICF labor price. I still think I'm going to be about 10 or 20% more efficient, but not game changing. The game changing is the schedule. So when we go into our projects right now with what we're bidding standard ICF pricing models because we don't know what we can give back to the customer because we haven't vetted out everything or all the problems that we're gonna encounter or still haven't encountered. I don't think we've encountered or will encounter that let's hang it up issue, but there's still probably solutions. There's lifting crane solutions, there's a lot of other variables that we're still vetting out and again, making mistakes, but learning from them. I gotta read notes here, sorry. Basically, what we do in setup in the plant is, as you can see the stock walls on the right, these are getting ready for our wood shop. We have a wood shop, we have a weld shop, we actually tack weld every one of our lintels. So when we put our lintels in, we're tack welding every one, and we do that for rigidity and for the basis that it literally just holds that whole section of the wall. Because my whole thing now is how do I keep this wall static and solid for that transport and lift where I'm not gonna deal with birds' mouths every seam and everything. We came to the realization that we're gonna have to glue all the seams. And now that is found out to be an ancillary benefit to that. In New York City, they have envelope specialists, as Steve was telling you.
Let me just jump in.
Yeah.
So, yeah, envelope consultants on large buildings are normal. Buildings leak sometimes. We've all seen that. ICF buildings don't leak as much, but you can't tell that to the ownership and the architects and the envelope consultants. I can't tell you how many envelope consultants I've had to deal with who are hired by owners, and they say, you finish that ICF wall, you gotta put something outside. You gotta mop on, peel and stick, you gotta do waterproofing.
Above grade.
Above grade. And I say, well, you know, we did 10, 11 apartment buildings, they don't leak, so you're wrong. They say, no, we're right. I said, well, how many ICF buildings have you worked on before? And the answer is usually 0, but they still know more than we do. So, a couple of jobs have come along, one we're working on now, a couple, and where there was an envelope consultant, and they're insisting that the owner go out of their pocket, a couple bucks a square foot, give or take, to put on something over the outside before the finish goes on, stucco, brick, whatever. It's just a waste of money, in my opinion. One job that we're working on now, which you'll see later, that consultant, when they heard that we were gluing the joints continuously, they said, oh, well, if you're doing that, then we don't need that other stuff on the outside. Because we were worried about water leakage at the joints. And we all know if you take 2 ICF blocks and push them together with friction, it's pretty good, but it's not watertight. If there's a crack or something, water might get in, especially if it's a fire hose. But mostly it doesn't happen because you don't have too many fire hoses hitting your walls, I hope.
I guess the end game is there that based upon the process itself, and the process itself gives you a unique advantage over your competitors, because if you're going to conventionally block a building in New York City and you're going to have to put a waterproofing membrane on it, and I can go up to that same owner and give them the same price for the ICF and they don't have to put that membrane on there, that's just one other aspect of what panelization benefits are. Let me open up the floor to any questions for a couple minutes before we get too far down and we can go back into it, or?
Well, if you have questions,
Yeah, that's right. If you have questions, anything we're saying, I don't want to get off topic, and I want to adjust them for you if you have any. This is a standard, this is what I call a splice plan. It's an ICF splice plan. I take the generic drawings from the structurals. I then do what's called a one-liner. If you ICF guys know what I'm talking about. The only thing we care about is the outside of the foam. We don't want the sheathing, we don't want this or that. So just give me a one-liner around the building. And so what we do, and then I dictate where I have to do this, or somebody with knowledge has to do that. Where do you put your splices? As you can see, I'm trying to turn a corner, because I want that integral. I want that, we are putting horizontal rebar in this job. This is not a helix job. So we're actually panelizing this with full horizontals and verticals. But as you can see, I left these components here as part of these splices. So we didn't have to do these, as you know, these take time out in the field. So if I can put all these together in the actual warehouse, it's better. I think the next generation is going to be segmenting these corners, segmenting these tees, because it allows me, in the factory, as you know, you gotta tooth these in, you gotta figure it out. If you're not on an exact 2, you know you're gonna have a splice. So if I'm gonna have a splice anyways, why don't I just splice it here and here? And that's the methodology of where we're going next. And that is where I can just produce a panel here that's 42 feet, and then I need to backdrop it, whatever, for the tee, and I have to back measure for the 90, and now I have my panel width. And now I just put them 3 components on in the field in lieu of just the one. So we take a splice plan like this. This is about 2,000 linear foot of wall. It's about 66 panels.
This is about 25,000 square feet of floor area on this apartment building. You'll see an image of it in a second. So how many panels total per floor?
60. This one's about 66 panels. So you're talking about 22,000 square foot of wall per floor. So then we take the panel, and then as you can see the isometric up in the corner, we flag out the red panel. That shows you in placement where it is on our property because these are large footprints. And then we literally try to put as much information on this panel that we're going to put into the wall. And this is still a work in progress. We do our lintels, we do all, window openings, our bucks. This one is a masonry opening job, so it doesn't have a wood buck. And then basically you can see the other, there'll be other plans that'll have embeds. There's a relief angle up there in that corner, up on the top of that wall. So these are all items that normally would be done in the field. We're doing them all in our shop. As you can see right here, we set these up. We'll make our inventory wall, and then we'll send it to our area where our wood shop is, where we'll send our bucks, and we'll pre-buck everything. Our weld shop will do split lentils or full lentils, and again, they're all welded and tack welded. And this shows the pop outs from the actual walls themselves. What you're looking at here was our very first day or week of working, where I built the entire wing in full scale. And the only reason I did that is, at first glimpse of this, I did not want to make a mistake dimensionally. So I want to make sure that if I had 4 panels, they're going to add up and the corner is going to be where it is. So I literally shot the pins down in the warehouse and built it in full scale. So I didn't have to worry about the IT stuff, because the IT stuff was not ahead of where I was in production. I was producing before I really had the IT straightened out. So again, learning curves. Again, just another
Well, that's the same drawing.
but that's the actual window, that's the actual wall itself. That's the finished wall of that drawing. As you can see the one T up in the corner, which is that T right here. This is that corner coming and returning this way with the 3 windows bucked out.
This is not at the job site, this is at our factory, our first location. We were just checking out the lifting process, wanted to make sure
Correct.
it would work.
We destroyed panels that day. Hilton Garden Inn basically was, is it a panelization project? No. What it was a 3rd floor. It was a 3rd floor that I experimented with when the weather shut down the job for a week. The owner went back to conventionally blocking it after that, and for a multitude of reasons, but one of them was not because it didn't work. It was an experimental type thing I did, and basically it kind of morphed itself into this project. This was our first beta project. We're actually landing 2nd floor panels tomorrow on the project. This project is a simple ICF project. It's an 8-inch cell all the way from foundation all the way up to the roof. They didn't go to 6s or even 4s. I don't know the reasons. The architects and engineers never drew an ICF structure before. And as you all know, I mean, that's one of the biggest problems is value engineering an architect that never has done ICFs. Sometimes it's sometimes easier to just go with it instead of trying to fight with people to change their method of madness.
I've often said to developers when I'm trying to talk about the process of ICF or panelization, I said, do yourself a favor, find an architect who's done it before, because why should you pay for them to learn on your dime? And the same thing with a structural engineer. Structural engineering should be easy, but some people look at the foam and the plastic and say, I don't get it, Literally, I've had that, and there's nothing to get, it's a concrete wall. But
This right here is a 0 lot line situation. I have a better story than that. Tishman, Akon Tishman called us. They have a church in downtown Manhattan, it's a school, and they basically have a 30-foot by 60-foot wall, a 1/4 inch from the property line from the lady behind them, and there's an alleyway. So 5 years ago, that church asked the lady if she could use the alleyway to bring her, the lady asked the church if they could bring their landscaping through the alleyway and into their backyard or whatever. And the school said, no. So now she said, well, you're not coming on my property, you're not gonna even lift anything on my property, and I don't know if you know about, there's actual underpinnings